Chapter review question number 14. Y wants to know if the 10 people in her group are as good at science as they are at art. She collected the end of term test marks for science and art and coded them. The data she collected can be summarized as follows. A. Work out the product moment correlation coefficient for x and y. So in part A, we need to calculate the product moment correlation coefficient, which is also denoted by the letter R. Since our two variables are x and y, we have a formula for product moment correlation coefficient as Sxy divided by square root of Sxx into Syy. So let's write the formula for Sxy, that is sigma xy minus sigma x into sigma y divided by n, all of this divided by sigma x squared minus sigma x upon n, sigma x squared upon n into sigma y squared minus sigma y the whole squared upon n. So let's work out the value of Sxy. Sxy is equal to 434 minus 67 multiplied by 65 divided by 10, and that gives us negative 1.5. Sxx, and that is equal to 465 minus 67 squared divided by 10, that is equal to 16.1, and Syy, that is equal to 429 minus 65 squared divided by 10, and that is equal to 6.5. So let's plug in these values into our formula. For R, we have Sxy as negative 1.5 divided by the square root of, we have 16.1 as Sxx into 6.5. And when we work it out, we get negative 0.147 to three significant figures. And that answers to part A, which is the value of product moment correlation coefficient for x and y. Now in part B, we need to find the product moment correlation coefficient of S and A. So S divided by 10 was equal to x. We had used coding here, and y is equal to A divided by 10. So now this is a linear coding, and linear coding does not affect the value of product moment correlation coefficient. What is meant by a linear coding? Linear coding is something that does not change the scale of the axis of the scatter diagram. So whatever the scatter diagram, it will be looking the same, but it will be either a squashed one or a smaller diagram, which will have the same pattern for the line. If it is a negative correlation, it will show negative correlation. If it is positive correlation, it will show the same orientation for the line of best fit. So R will remain unchanged. For part B, it will be negative 0.147. In part C, we need to write down whether or not it is true to say that people in Y's group who are good at science are also good at art. Now, people who are good at science are also good at art. This could have been true if the value of the product moment correlation coefficient was a positive value. So, people who are good at science are also good at art. So, this should have positive value for R, because it is a positive correlation. There is other type of correlation where we have, for example, people who are good at science are not good at art. So this is a negative value for R. Okay, and then there is a value for R, which is value of R is 0. So when value of R is 0 or close to 0, it's basically no correlation. So here, if we discuss it, since the answer is negative for R, so negative value for R means that those who are good at science are not good at art. But this is not a very strong correlation, as a value, though it is negative, is close to 0. So there is no evidence here to say that those who are good at science are good at art, because for this, the value of R should have been a positive value. Now the next is, it is a negative correlation, but even though it is negative, it is not very strong because the value of R is 0. So there is a very weak correlation between the fact that those who are good at art are not good at science.